Hi guys, how's it going? In the last video we created this script in our controller which basically uploads all the images. However, there's one thing I would like to point out. So I said here that give me the image with the file name you're reading, and if the count is 0, that means there is no image with this file name currently being read. Then go ahead and create one. Otherwise, go back to the view with this error message. Now after you load the first time, for rapid prototyping this is okay, because once you upload them you just don't want to do anything, you want to play with your game. But if you add a new image later on, it's going to go over each one of these. But with the first one, when it finds a match, that there is a match returns more than 0, it's going to end the script and go here with an error message. So you won't be able to upload any new image if you add afterwards. So in order to fix this, we'll comment out this and just add a keyword continue. So what it does, basically it says if you find a match with the file name currently being executed, if there is a file with this name in the database, if you find a match greater than 0, then I want you to skip this part, just continue with the next one, next one, next one, and so on. To display this, to demonstrate this, I'm going to save this image. It's not there in our database currently or in this collection. I'm going to save it, and then what we're going to do essentially is going to run upload, and it's going to go over each of the files. And let's open up our database and refresh, and you see we have 72 images, not 71. In the last video we had 71 images, and now you can just keep adding new images in your folder. We just added this one. If you want, you can keep adding new images and keep pressing this button. It'll keep checking if each of the images exist in the database, otherwise it'll upload that. So that's all with the images. In this video we'll work on our algorithm and try to learn more about the algorithm and see how we can make use of it. So let's go over here and see what this algorithm is. So it's called ELO algorithm, developed by Dr. Laravel ELO, who was he was a master level chess player himself, and he primarily he developed this to predict a chess player's expected ranking or his chances of winning with every move. So essentially what it does is there are some assumptions that so there's a performance rating algorithm. We won't be using this, we won't be going into this, but we'll be basically looking at the mathematical representation of this algorithm, which in our computing we can use. So what it says essentially is that in a particular game event, there are two players, and one of them will win, one of them will lose, or they can have a draw against each other. Now every time they win, you can add 200 points, or you can reduce by 200 points, but I have chosen 400 points. More points you add, their scores are going to be further apart, so it gives better visual representation. And so essentially what we're trying to do is, let's open up our editor and close this one here. This is our game model. In the game model, every game we play between two players is going to have static functions, which are basically the algorithm is going to be in these functions to do something, and we're going to be calling them in the game controller. So I'm going to open this view, which is side by side. Let's go ahead and hide this one. We don't need this. Sidebar is hidden, so we can go and work here. So very first thing, what are we trying to do here with the algorithm? The algorithm says that give me the players and set the score to 1500, all of them. With every win, we're gonna input here if it wins once, 1, 2, 3, 4, whatever, accumulate, and losses 1, 2, 3, 4. And with every game, either it wins or loses. In both the cases, we are going to update this score. And then if we have a win, if we have a loss, and if we have a score, we can calculate the rank. So what essentially we are doing here is, in every game, if a player wins, there's only one possibility: he can earn 1 point or he can lose 1 point. So that is how the game works. But we also need to calculate an expected score or expected result value. So before the game is played, there's an expected result. The player, let's say there are two players, A and B, and player A has a rating of 1550 and B has a rating of 1420, which means player A has higher chance of winning. So the expected winning should be, let's say, 0.5. But after the game is played, player A becomes 1. He has a actual score of 1 and B has 0. So we are going to alter the score. We're using this formula. That way the gap between the expected score and the real score reduces, and every time it reduces, it corrects itself. The algorithm learns itself and corrects itself, and therefore the expected score is very close to the final score. And that's how you evolve, basically the scores. So the probability is very close to the actual score. So prediction is very accurate. How we do that? It has a couple of steps. Number one, every player has basically a starting score of 1500, which means if you're calculating the expected score, first you have to calculate the expected score for both the players before the game is played. Now the expected score is going to be with this formula. If you're calculating for player A, this is the formula: 1 divided by 1 plus 10 raised to the power of rating of player current score of player B minus current score of player A divided by 400. We are adding 400 points each time and reducing 400 points each time. You can change it to 200, 600, depending upon how you want to represent. Now, if you have a very large number of players, let's say million, you want to keep this number higher so the gap is higher. But otherwise, 400 works pretty good for most of the chess games. For the player B, you're gonna use this formula, which is 1 by 1 plus 10 raised to the power of rating of A minus rating of B. For the A, rating of B minus rating of A divided by 400. And we're going to represent this formula here. So let's calculate here. Let's write a comment here. Calculate the expected score or outcome. Expected score is based upon rating of player A, which is RB, rating of player A and rating of player B. I'm just going to write RB and RA. We can use same function for both the players. All we have to do is just switch the order of these arguments. So rating of player A will come first if you're calculating for player B. We're calculating for player A in this. We are like trying to show, so rating of player B comes first. But we can just switch the arguments and this function will work for both of them. So we're going to return 1 divided by, as it shows here, 1 divided by, and then we're going to say 1 plus, here we're going to use a PHP function POW, which is going to take a base value of 10 and it's raised to this value, which is going to be RP minus RA. Sorry. And here I'm going to divide it with 400. So that's going to give me the power of, that's going to give me the expected score. And please excuse me for a second. I've got a phone call. Sorry about that, guys. Everything is okay. Let's continue. Alright, so basically what we're trying to do is return this value, and that's it for this function. Now we're gonna write a comment here. So we will be calculating the new score. So new winner score in this function. So after we have expected scores, we want to calculate the new score. Now how the new score is being calculated is this formula, which is, for example, for the player A, if you want to calculate the new score and the player A is the winner, we will be writing for the winner and the loser both. Doesn't matter which player is winner and which player is loser. We will be targeting these functions based upon our requirement. We know which one is loser and winner based upon the request that's coming from the view when we click. When we click on an image, we know it's a winner. The other one is obviously a loser. Anyway, so this formula says the new score for player A, which is RA, what do you call that? The new score is going to be equal to the current score in the database plus a constant value, which is anywhere between 16 to 32, I think. I have used 24. I'm going to use 24 because that's somewhere in the middle. You can use this constant based on how precise, how these results will come out to be. Different companies use different constant value for different results, and they have their own reasons, but I have no reason, so I just use 24. So current score plus the constant value in the brackets, we are going to give expected score here, which is going to come from this formula we just defined, and this is going to be the actual score. Now actual score in a game is only 1 or 0. So whenever there's a image comparison, we pick an image that wins 1 point, but the other image loses and doesn't win anything. So what this formula is trying to do, they have tried to simulate this by taking an example. For example, an image has starting score of 16-1-3 and it plays 5 games. It loses to a player with a rating of this and draws for a player with rating of this, then again defeats a player again and loses to another player. So actual score, which is this score, the SA, actual score, in the first case it loses to a player, so the score is 0 because it lost. It has done a draw, so it's going to be 0.5, half of it. Then it has defeated a player, so it's going to be 1. It had defeated a player, it's going to be 1 again. And it has lost to a player, so it's going to be 0. So total score is going to be 2.5. Because they played 5 games, we're going to be playing 1 game. So in our game, it's going to be 0 or 1. Anyway, let's continue with this example first. Let's talk 2.5. And based on the current score, the current rating of player A and player B, who are playing the game against each other. For example, player A is 16-1-3 in this case, and B is going to be, in the first game is going to be this, second game is going to be this, the third game is going to be this. Based on those two values, we calculated the expected score. The expected scores are 0.506 and stuff like that, like so. And total of them become 2.8. So expectation was higher and actual score was lower, which means the algorithm is going to correct itself and bring the score down actually. The score actually going to reduce, like 1601 from 1613, it has to reduce to 1601, although the total is still winning because 2.5 times is more than, is basically 50% of the 5 games, But essentially what algorithm does is, we started with a score of 1500. In this case, it's like current score before these games were played was 16-1-3, and we had an expectation of 2.8 according to this score, according to these values, and based for their opponents' values, because opponents were having lower score. But the end result came out to be a draw or some sort of even value for both of them, which means their scores will be updated to higher score, and this score will be brought down to lower score. So algorithm will make a correction for the scores. So next time when these games are played, this value, the expected value, is very close to the actual value. So essentially when you play 1 million games, your actual score and your expected score is going to be like pretty much the same. That's the whole idea of creating a probability. So by looking at their scores, after you have played 1 million games, when there is a next game after the 1 millionth game, that one game is not going to make so much difference because someone has played 1 million games for the players. So the score rating will change like minutely. So basically just looking at their scores, you can tell this is continue to win or continue to lose. That's just probability. So essentially we're using the algorithm to target the imaginary score that we assigned at the beginning of the game. But as we move along, we play the game, we want to update the score, and essentially we are trying to update the new score. That's what we're trying to do. For a winner, the score should go up. For a loser, the score should go down. In this case, it's a winner, but it's a score has to adjust for the 5 games, so it has adjusted to 1601. But I hope you understood what I was trying to say. In other words, the expectation and the actual cannot be far out. They have to match in a long run. That's the whole idea of algorithm. In the beginning they will be out, but then algorithm corrects itself over the period of time. So how to represent this winning? Doesn't really matter winning or losing. The only thing different is this score, this value here. For a winning it's going to be 1 minus, and every time you subtract some expected score of, let's say, 0.506 from 1, it's going to be positive, which means it's going to multiply and keep this score increasing. You know, this score will keep increasing. But if it's 0, it's going to be minus something, which is going to bring the score down. So that's the idea. So we'll represent here return. We're trying to return a value. What we're trying to return is the current score, which is the current score of player A, plus a constant, which is going to be, so we'll define here score, we'll define here a constant. I'm going to set it to, let's say, 24. It's an optional, it doesn't need to be provided, but if you want, it'll be set to 24, but if you want to change it, you can supply a third argument. And then it requires expected score. So expected score is going to come from here, which is EA, and we are supplying here EA. That EA is exactly this. So expected score is based upon the current score, but the current score of opponent as well as the player, and it's going to come out from there, and constant is already set. So we're going to multiply the constant here, as the formula says here, multiply with the in the brackets, and we're going to here put, for the winner we're going to put 1 minus expected expected, and that's it. For a winner it's 1 minus expected. It's going to stay positive, and we can just copy this whole thing and paste here, overwrite it basically, and we're going to say loser score, and we're going to say loss. It takes the same set of arguments, except this is going to be 0, because the loser won't earn anything if it loses the game. And that's it. That's how you calculate the new score for the winner, new score for the loser. And how do you calculate the rank? So essentially we're going to rank for our top 6 players, you know. So how we're trying to rank is, we have a score here, let's say 1697, and we have wins, how many times it has won, for example 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have losses, it has lost 5 times maybe. So by using a certain formula we can rank our players. So we're going to say return, I'm going to say score, and then I'm going to divide it by 1 plus, I'm going to say here give me the losses and give me the wins, and that's it. So we're going to give here losses, and we're going to give here win, and also we're going to give score, sorry. So basically by giving the score, losses and wins from our database, we can give losses and wins and score, we can get the rank, and that's the formula for that. And it's basically how you calculate the performance. So basically you know how many times we have lost, how many times we have win, you divide them together, and then you add it to 1, and then you divide the whole score with that value. That should give you a rank. And I think it's mentioned somewhere here that the performance rating, this one here, somewhere here it's mentioned the performance rating. So I just used that formula. Yeah, that's nothing, that's simple mathematics. I mean, if you have, if I give you these three rows, if I give you 3 players or 2 players with 2 different scores, I can tell you how many times they have won and lost. Tell me which one has a higher rank. That's how you're going to do. The score divided by the losses divided by the wins, and that's how you calculate the rank. That's simple mathematics. I don't know how to explain that otherwise. But if you have a better way to rank it, just let me know. We'll do that. But I think this one is pretty good. Okay, so that's everything about the ranking. We're going to put a comment here, so we don't forget. A good programmer always puts comment. We're going to say update, calculate the new rank, calculate the rank. there's a problem here. For example, if I divide the loss by wins, it's going to return me some kind of decimal number, but my rank, I would like to keep it like rounded to the lowest decimal or something. So I'm gonna round it, use here the round PHP round function, and that's going to round it off to the nearest digit, you know. But then there is another problem here, that what if an image has already won 3 times but lost never, which means it's going to be infinity or something. If we try to put that 0 in our formula, if we put here 0 in our formula, it's going to 0 divided by 5, it's going to fucking break our application. So I'm going to run a check here. If the score if the score is 0, I know score is not 0, but just in case, if the score is 0 or losses is 0 or wins is 0, then return 0. Don't change the rank. I don't want to change the rank. If any of these 3 values are 0, because if you divide 0 by 0, 0 by something, it's going to be infinity or something, so, or undefined or something, you know. So if any of these values is 0, I want you to return 0, otherwise return the score, and see you later. That's all we want to do in our algorithm. Take an example. Let's go to our image controller. And here, somewhere here, let's just say here, we're gonna die and dump a variable called rank. What is this variable essentially? We're gonna call a static method. Let's say we're gonna call all these 3 methods one by one just to test if they are working. So we're gonna give a rating of player A and player B. It's gonna give us an expected response. For example, expected. Now rating is going to be 1550, and the next rating is going to be 1450. And I'm gonna say expected. Let's change to var dump. Or die dump was enough. That's good. Now let's go back to our here and just refresh, and that says there is an error in our image controller. Image controller has, because this variable cannot be found. So I'm just gonna call it var for now, okay, or result. And refresh. And in image controller, line number 21. Sorry, it's not rank, it's result. And then we have this. The reason it hasn't imported yet, so it hasn't imported the class. Did I save it or? So let's just say here. If I do that, what does it do now? It complains line number 22. Oh, sorry, I haven't put the end of the line. I sometimes do that. Sorry about that. So just make sure to put the end of the line comment, and now it imports automatically and everything is good. I think it's going to give another error, which is game.php in line number 15. So in line number 15 there's nothing wrong, but I didn't put end of line here, so make sure after the protected fillable put an end of the line here. Sorry about that, I keep doing these mistakes, but that's part of the game. Now game.php line number 35 has this error, this OR statement, and what this statement is essentially saying that you cannot compare like this. So you have to wrap them inside the parentheses, all of them, and now it will give us the result. So that's the, let's go back to image control. So based on these 2 scores, the expectation is this, which is some kind of fraction number, you know, like some kind of long number. That's fine. We have the expected response, which is this, and it's stored in the result, or we can call it expected. And then we can delete this for now. Now we want to do is calculate the win, calculate the new score. We're gonna call game. It has win, and that requires current score. I forgot how we do that. Let's go back to game once again. It requires current score and it requires expected scores. So the current score is, let's say the current score is 1550. How did we calculate this? The expected, if you're calculating for player A, you have to give the player B first, which means we are calculating for the winner. So in this case it's going to be the player A. So we're going to give here 1450 and then we're going to give the expected. And let's see if this variable, when we die and dump, what it gives us. We have a 0.35, and when we do that, it gives us a new score of 14,515. Sorry, I put another 0. Delete that and refresh. So as you can see, the score has gone up because we are saying the player A has won, because in this function we declared the loser. This is not really about the loser, it's about calculating which player you're calculating comes the last. So we are calculating for player A. Let's say this is the player A in this function, player A and player B, the rating of player A and player B. If you're calculating for A, the A has to come last. You have to subtract from B. Doesn't matter if it is less, is lower or higher, because if it is lower, it's going to return a lower expected value, the 0.35 or something. But anyway, essentially in the win formula is for if this player has won. If 1450, the player A was the winner, then we use win static method, otherwise we use loss static method. He was a winner, so it has increased the score. But if he lost and I refresh, it has gone down. So 1450 has become 1441. Now that's pretty good. That's pretty good. But we haven't rounded off this. Maybe we should do that because it's giving in decimals, as you can see. So if I round off this, if I round off this one too, then it's going to be a whole number. Yes, it's still like, I don't like this .0. Anyway, that's another thing. So our algorithm is, we try to understand this whole article like really quickly, but I really would like to encourage you to read this particular set of information, starting from this mathematical details to this like a couple of times. You can skip this notation. This is probably easy, because if you look at this, the same formula works for both of them. The denominator, it's only the numerator that's changing, QA, QB. The denominator is same. And anyway, go over it, try to understand a little bit more, and I'll see you soon in the next video. Our algorithm is done. The next thing is to create a view and then pull in some images randomly and start clicking on them. We need to make sure that our clicks are detected by the controller, and which click is winning click, which click is, of course, our click is always winning, and the other one is a losing click or losing image, sorry. And then we will run these static methods to update the score in the database. Once we can update the score, we'll get the rank, and that's the whole idea, to get the rank of an image. And we're on the right track. If you find any difficulty in understanding this, let me know. Maybe I can make another more detailed video, but trust me, stay with me. When you build the game view, the view for the game, and then you start ranking them, you will fine-tune these values. Like you can use 200 points basis, and you can change the constant, and your ranking will start working better. But it doesn't really matter what values you use. Longer you play, the algorithm will keep correcting itself, its score, and eventually the probability will become very, very precisely accurate to the actual result. So thanks for watching. Make sure to like and subscribe, and I'll see you in the next video. Have a good one.